So here I'll start by squaring that equation, and that means f of x plus 1 is 9701 squared. So just remember that anytime you square these radical equations, you have to always make sure you substitute your solutions back and that you don't end up with any extraneous solutions. So we'll confirm that at the end. So that's something to always keep in mind. Now here, this looks like our difference of squares, and I'll plug that in on this side as well. And I'll write this as using the difference of squares identity. A square minus b square is a minus b times a plus b. So that becomes 9701 plus 1. Then 9702. Now if I call that a, then this is a times a plus 2. And you can easily see a has to be 9700 because that's a plus 2. So our solution is a is 9700, and I assigned a to be x squared plus 3x. Now at this point, we can find the sum of all real roots, because for this quadratic, the sum of the two roots would be minus b over a. That's the formula for the sum of the two roots for a general quadratic equation. B here is 3. And a is 1. So the answer is minus 3 and would be done here. But just a couple other things to be careful. One is some of the students might try to solve this, and you will see that this will just factor to x plus 100, x minus 97, because you'll see that will give you minus 9700. So the two roots are minus 100 and 97, and indeed they do add up to minus 3. But we also want to make sure that if we were to plug it back into the original radical, that this doesn't give me any extraneous solutions. Now, if x, we know that for both of these roots, x squared plus 3x is 9700, and that's what you'll get if you were to plug that back in. So we don't have to actually do that work. We just plug that back in, 9700 times 9702, and there are no extraneous roots here. So that's just something to keep in mind. In certain questions, you could end up with extra roots. That's not the case here, but just something to keep in mind. So to summarize, the answer is that the two roots add up to minus 3, choice D.